Uh, Good evening, everyone. Am I audible? Hi, hello. Am I audible? Hello.
Good evening, sir. It is audible.
Okay, fine. So, is my screen visible?
Yes, sir. It is visible.
Okay. Okay. So, I'm Pankaj Kapdi, and I'm an NPTEL TA for this course, and so this will be our fourth live session, and the problems for this session are related to the lecture videos for the fourth week. The topics are Taylor's theorem for two variables or more than two variables, and with how to find maxima and minima of functions of several variables. Okay, so let's start with the first problem. So this is first problem which says that using Taylor's formula, we have to find quadratic approximation for the function sin x into sin y at the origin. Okay, so here is the Taylor's theorem. This is the expansion for a function of two variable. So this is here we are expanding the function around the point x naught comma y naught. Okay, so we will use this expansion, and because we have to find a quadratic expansion, right? We have to take a quadratic uh, approximation. So we will take these terms up to order 2, like these terms, and rest of them we will ignore. Okay, so for us the function fxy is sin x into sin y. Okay, and we have to find the approximation of this function around origin. That means if you use Taylor's theorem, okay, just put x naught equal to 0 and y naught equal to 0 here. So put this x naught 0 and y naught 0. This will be your become your h. This will become your x, right? X in place of x naught plus h, and this is y. Okay. So what we get is f of xy is f of 0 comma 0 plus the partial derivative of x, partial derivative of f with respect to x at origin into x plus partial derivative with respect to y at origin into y plus half of the second partial derivative with respect to x at again at origin into x square plus fxy at origin into xy plus fyy, this two times partial derivative with respect to y again at origin into y square. So this is our approximation, and we will just ignore rest of the terms. So for this given function sin x into sin y, we have to find all these values, all these partial derivatives at origin. Okay, let's see what is our partial derivative with respect to x. So what is fx? It is cos x into sin y. Why? Because we are differentiating the function with respect to x, so sin y will treat as a constant. So the derivative of this function with respect to x is cos x into sin y. Again, what is fx? X, the again we differentiate with respect to x. This is minus sin x into sin y. Okay. Similarly, what is fy? It is sin x into cos y. What is fyy? Is sin x negative sin y. and we have to also find this f of fxy. So partial derivative of fx with respect to y. Okay, so we'll differentiate this function, either this function or fy. It doesn't matter because in this case mixed partial will be same. So what is fxy? We have to differentiate fx with respect to y, which is cos x into cos y. Okay. Now notice that we have to find all of these values at origin, right? F of 0 0, fx of 0 0, fy at 0 0. Notice that sine of 0 is always 0. So whenever there is a sine term in this fx or f double x, f double y, that value will become 0 at the origin, right? Because sine of 0 is 0. So this will vanish. Except fxy term, every other term will vanish. Okay. That means fx at origin is 0. Fx, this is 0. Fy at origin is 0. F double y at origin is also 0. Okay. And notice that only term which survives is f of xy at origin, and that is equal to 1 because cos of 0 is 1. Also, f, the function itself, takes value 0 at origin. Okay. Now you just put all these values in the series which we have constructed. So you will get that. Okay, let's denote this series by some other symbol because the f we are denoting the function. Okay, so we will denote this series by the polynomial because it's just a polynomial and two variables. So we'll denote it by pxy. So this is our approximation. So what will be pxy? It is simply xy, right? Because the only this particular term survives and everything is 0. So the option C is correct. Okay, you can all write, you can note down this particular solution of this problem if you want, then we can move again.
Excuse me, sir.
Yes.
The questions are very small letters. You can please you can zoom it so we can see clearly.
Okay.
Thank you, sir.
Is it fine now?
Okay, sir. Okay, thank you.
Okay, so if you all have noted down, then we can move ahead. Okay, so the final answer is Pxy is equal to xy. Okay. Should I move to the next problem?
Okay, sir. We can go next question.
Okay, so this is our next problem. So in this particular problem, we have to find the stationary points of the given function. So stationary points, or sometimes we call them critical points. So these are those points where there is a possibility of attaining minimum value of the function or maximum value of the function. So these minimum and maximum are relatively. So locally, in a certain neighborhood of the point, the minimum or maximum may attain at these points. So these points are called stationary point. And how do we find them? These points are just solutions of the first partial derivative and second partial derivative. So you find the first partial derivative, put it to 0, and calculate second partial derivative. No, calculate the first partial derivative with respect to x and y, and then make them equal to 0 and find the solution at what point the first partial derivative vanishes. Those points we call them critical points. Okay. For finding these particular points, okay, what is our function? Is okay, our function is fxy equal to x to the power 4 plus y to the power 4 minus twice of x square twice y square and plus 4xy. Okay, and we have to find the critical points of this function. What we will do, we will just calculate the first partial derivatives of f with respect to x and y and put them equal to 0. So what is fx? 4x cubed minus 4x plus 4y, and fy is 4y cubed minus 4y plus 4x. Okay, so fx equal to 0 implies that x cubed minus x plus y becomes 0. Fy equal to 0 implies that y cubed minus y plus x becomes 0. Now we have to solve these two equations to get the values of x and y, like at what point these will become 0. Okay, so what we'll do, from the first equation, let's call this first and second. From first equation, what we get, that y equal to x minus x cubed. Okay, or we can write it as x in bracket 1 minus x square, and we will put this particular value of y into the second equation. Let's call it the equation 3. Put 3 in equation 2. Okay, so y cube. So y cube means x cube 1 minus x square whole cube minus y. So x and 0. Okay. Now notice that we can take x common. So this becomes x times x square 1 minus x square cube minus 1 minus x square and plus 1. This becomes 0. Okay, so either x is equal to 0 or the second part term becomes 0. Okay, so if x is non-zero, let's say, if x is non-zero, then we have x square into 1 minus x square cube. Okay, this is minus 1 minus x square plus 1 becomes 0. Now we just simplify it further. X square 1 minus x square cube. Okay, when you open this bracket, so 1 is in 1 will be negative. So this is minus 1 and plus 1 will cancel with each other, and you will be left with x square. Again, you can take x square common. 1 minus x square cube plus 1 will become 0. Okay, so because we have assumed that x is non-zero, we get 1 minus x square cube must be equal to minus 1. Okay, now if some cube is minus 1, that imply that 1 minus x square must be equal to minus 1, right? Because this cube is minus 1, and that will give x square equal to 2, and this will imply that x is plus minus root 2. Okay, yeah, now because we have assumed that x is non-zero, so what will happen when x will become 0? So notice that we already have these two equations, first and second. When you put x equal to 0 in the first equation, or x equal to plus minus root 2, what do you get? When x is 0, y is 0. When x is root 2, y is minus root 2. And when x is minus root 2, y is plus root 2. So this comes from equation 1. You can use equation 1 for this. and therefore the critical points are or stationary point are 0, 0, root 2, minus root 2, minus root 2, root 2. Okay, so this, that is our answer. D is correct. You can note down this solution, and then we'll move further.
Sir, please show the question, sir.
Okay. So let me know when I should move to the next problem. Okay, let's move to the next problem, the problem 3. Please note it down. So again, in this particular problem, we have to find the critical points of the given function. Okay, what is this function? This exp, that means the power of e. Okay, so fxy is e to the power minus x cube by 3 plus x minus y square. Okay. For simplicity, we write it exp, exponential function, and we have to find the critical points for this function. Okay, so for critical point, we will evaluate the first partial derivatives with respect to x and y and put them equal to 0 and find their solutions. So what is first partial derivative, like with respect to x of this function? Fx is equal to, so, plus x minus y square into differentiate with respect to x, apply chain rule, and we get minus x square plus 1. Okay, what is the partial derivative with respect to y? Again, exponential of minus x cube by 3 plus x minus y square into the partial derivative with respect to y of this particular function, applying chain rule, we get minus 2y. Okay, now notice that fy becomes 0 if and only if y is 0. Okay, why? Because the exponential function is always x value is positive. So exponential function is always positive for every x. Whatever the value of x is, it's always positive. So fy becomes 0 at y equal to 0. Okay, again fx is 0 if and only if x square equal to 1, that is x equal to plus minus 1. So what are critical points? One comma 0. And note down the solution. And if there are any questions, you can ask me. Okay, can I move to the next problem? Just let me know when you are finished writing the solution. Okay, so let's move to the next problem. Problem 4. Okay. Again, in this particular problem, the function of two variable x and y is given, and you have to tell which options are correct out of these given four options. So basically, you have to find a maximum and minimum value of this function. And also where that particular maximum or minimum attain. Okay, so what we'll do, we'll again first find the critical values, because the maxima and minima always attain at critical values, and then we'll investigate those critical values one by one if there are more than one critical values. Okay, so how do we investigate these critical values? So there is something called differentiability test to apply, which we can apply to find maximum and minimum, and it is here in the next slide. So what we will do, this is first step I have already told you. This step is to find critical values. Okay, compute first partial derivative with respect to x and y, put them equal to 0, and get those critical points. Now, at those critical points, we compute some of these. So let me tell you what is R, S, and T. Okay, so assume that a comma b is a critical point. Okay, if a comma b is a critical point, then here R denotes the first partial derivative of the second partial derivative with respect to x at a comma b. S denotes this mixed partial derivative at a comma b, and t is the second partial derivative with respect to y at a comma b. Okay, we compute all these values r, s, and t, and if r is negative and rt minus s square is positive, then at ab the function attains its maximum, local maximum. Okay, if rt minus s square is positive but r is also positive, then it attains its minimum. If rt minus s square is negative, then we say that the point is a saddle point and no maxima or minima attained at that particular point. So there can be point where there is no local maximum and no local minimum. but still it can be a critical point. Okay, so such points are called saddle points. But if RT minus S square becomes 0, then we cannot say anything. We cannot apply this derivative test, and we have to further check some by some another way. Okay, so in this particular problem, we will apply this derivative test, and for that, first we have to find the critical values. So what is our function? Okay, so the function is fxy is equal to xy times a cube a cube 1 over x plus 1 over y, right? Okay, let's find first partial derivative with respect to x. Okay, what is fx x comma y? So we'll differentiate with respect to x and apply chain rule whenever required. So here you will get y plus a cube, in bracket we will get minus 1 over x square, and again fy x comma y equal to this partial derivative with respect to y is equal to x plus a cube. Now notice that fx equal to 0 implies that yx square is equal to a cube, and fy equal to 0 implies that y square x is equal to a cube again. Okay, notice that x and y are non-zero because the function is well defined. So 1 by x is well defined, so x cannot be 0. Okay, so what we are doing, we are setting them equal to 0 and multiplying both sides by x square. So we'll get this first two equation. Okay, so both yx square and y square x are equal to a cube, and therefore yx square must be equal to y square x. Now because xy is non-zero, we can cancel xy from both sides, and this will imply that x must be equal to y. Okay, now if x is equal to y, from this first equation, if you say that it is first equation, then if x is equal to y, then what we get x cube is equal to a cube. That will imply that x cube must be equal to a cube. Okay, and this will imply that x is a. So what is our critical point? A comma a is a critical point. Okay, now we have to further find the second derivative. Okay, for these functions, those are s. First let's find the second derivative, fxx. So we'll differentiate fx with respect to x. Okay, so what we'll get is 2a cube divided by x cube. What is fyy? 2a cube divided by y cube. And what is our mixed partial? Derivative of fx with respect to y. It is equal to 1. Okay. Now what is our r? This is fxx at critical point, that is a comma a. It is 2. What is fyy? Which is this is t at critical point a comma b, which is a comma a in this case, and that is again equal to 2. And what is s? S is equal to fxy at a comma a. This is equal to 1. Okay, so now we apply the derivative test. What is rt minus s square? 4 minus 1 is 3. It is positive. And r is also positive because this rt minus s square and r both are positive. It says that by the derivative test, we have that a comma a is a point of local minimum. And what is the value of function at a comma a? So f of a comma a, f of a comma a is the lowest value. Okay, so this is a square bracket में a cube times 1 over a plus 1 over a. That is a square plus 2a square, and that is equal to 3a square. So the minimum value of the function is 3a square, which attained at a comma a, and therefore what are correct options? So a comma a is a stationary point. This is correct. And the minimum value of the function is 3a square is also correct. So the option a comma d are correct. You can note down this solution.
So please show the question for a few seconds.
What should I show? This question?
Yeah, few seconds.
Yes, fine.
Okay, sir. Thank you.
Okay, so have we noted the solution? Okay. So should we move to our next problem? Okay.
Sir, what about answer C? You told only A, B is correct. A, B are correct.
A and D are correct.
D. Okay, sir. Okay. Thank you, sir.
Okay. So okay, let's move to the next problem. Okay. Again, we have to find absolute minimum and absolute maximum of the given function in a certain domain. Okay, the domain is given as R. So this R, so it's a disk of radius 1. Okay, so on the plane, this is our domain. So draw a circle of radius 1. The whole inside is your domain of the function. So x and y can take values from this disk. And we have to find the absolute minima and maxima. So what is the largest value of the function and what is the minimum value of the function? Okay, in this particular domain. So we have to investigate the critical values of this function inside the disk also and on the boundary also, because the maxima and minima can also lie on the boundary. Okay, so we have to treat the boundary case separately. Okay, so if maxima or minima lie on the boundary, that means that there is a constraint. Constraint means your values of your variables x and y, they have some relation, okay, which satisfy on the boundary, and you have to maximize your function with respect to that relation, that condition, that constraint. Okay, so we'll just take two cases and then I'll explain you the method of Lagrange multiplier. Okay, so what was our function? X square plus y square minus x square into y square, right? Okay. And first assume that your xy lies in the interior of the disk. So interior means that x square plus y square is strictly less than 1. Okay, and then first we have to find those critical points. So let's see if there are some critical points or not for this function. For that, find first partial derivative is 2x minus 2x y square, and fy is 2y minus 2y x square. Okay, so fx equal to 0 imply that 2x, this will become 0, right? So so this will imply that either x becomes 0 or 1 minus y square becomes 0. Either x is 0 or y is plus minus 1. What about fy? So fy equal to 0 implies 2y times 1 minus x square becomes 0. That means either y equal to 0 or x is equal to plus minus 1. Okay. Now notice that whenever y is plus minus 1 and x is 0, that means the point lies on the boundary. Okay. So but we have assumed that x square plus y square is less than 1. So in the interior there is only one critical point. So 0 comma 0 is the only critical point in the interior of the disk, and that disk is R. Okay. Now we will consider the boundary of the R, the boundary of the disk. Now we have to again find this maximum and minimum value of the given function x square plus y square into x minus x square into y square, subject to the condition that x square plus y square is equal to 1. Okay. Now we have to find uh, this maxima minima subject to the condition that the x square plus y square is equal to 1. That is, the point of maxima or minima lies on the boundary of a disk. Okay, so this condition gives a constraint on the values of x and y. So there is a relation between values of x and y, and that relation is that the point has to lie on the circle of radius 1. Such optimization or maximization minimization can be done using the method of Lagrange multiplier. So in the method of Lagrange multiplier, what we do, uh, okay, so the here the problem is you have to maximize or minimize some function with respect to a constraint that phi of xy becomes 0. So there's another function which gives you a relation between your variable x and y, and you have to maximize or minimize according to this relation, this constraint. Okay, for that we will form this auxiliary function. So what is auxiliary function? We just take sum of these two functions, multiply by lambda to phi. So fxy plus lambda times phi xy. Okay, and then take first partial derivatives, it is fx, and if you take partial derivative of capital F with respect to x, you will get this equation and put it equal to 0. Take partial derivative of capital F with respect to y, put this again equal to 0. Basically we are finding those critical points only, but on the boundary. Now again, because there is another variable lambda, we differentiate with respect to lambda also. So what is f lambda? Is just phi of xy, and we put equal to 0. We will also put this equal to 0, and this is just our constraint. Okay, the f lambda is our constraint. This is our constraint, and then we will again find critical values with respect to these conditions x, y, and lambda, and then we will see which points attain maxima or minima. Okay, so in this case, what is our phi? Because this is our constraint, right? So phi of xy is x square plus y square minus 1. Okay, so what is our problem? Our problem is either maximize or minimize the function fxy subject to condition that phi xy becomes 0. So this is our phi xy and this is our fxy. Okay, Now we form this auxiliary function with capital F, x, y, and lambda of three variables, and that we write as fxy plus lambda times pi xy, right? In particular, what is this function? X square plus y square minus x square into y square plus lambda times x square plus y square minus 1. Okay, so this is our auxiliary function. Let's find first partial derivative with respect to x, y, and lambda. So what is fx? Partial derivative of f with respect to x, it is 2x minus 2xy square plus lambda times 2x. What is capital Fy? Again 2y minus 2yx square plus lambda times 2y. And f lambda is nothing but the constraint x square plus y square minus 1. And then we put all of them to equal to 0. Okay, so now what we will get? So fx equal to 0, that implies, now take 2x common. What we get in the bracket? It's 1 minus y square plus lambda is equal to 0. Fy equal to 0 implies 2y 1 minus x square plus lambda, this becomes 0. And f lambda equal to 0 implies that x square plus y square is equal to 1. Okay, so this is just our constraint. This we already know that x and y satisfy this equation. Now we have to find values of x, y, and lambda. Okay, so because we are on the boundary, assume that x and y are non-zero. Okay, x can be 0 on the boundary, but if x is 0 on the boundary, then we know what is value of y. Okay, so consider this first equation. The first equation gives either x is 0 or lambda is equal to y square minus 1. And second equation will imply either y is 0 or lambda is equal to x square minus 1. Okay. Now notice that because we are on the boundary, both x and y cannot be 0. Okay. Xy cannot be 0 because we are on the boundary. In the interior, we already have a critical point at the origin. Okay, so if x becomes 0, then what will happen? We have third condition also. So x0 implies y is plus minus 1 from the third condition. Y becomes 0 implies x is plus minus 1 again from the third condition. And now let's see what will happen with this two equation. This lambda equal to y square minus 1. We have y square minus 1 equal to lambda, and that is equal to x square minus 1. This will imply that y square is same as x square. That is x minus y square is 0. That is x minus y, x plus y becomes 0. So implies either x is equal to y or x is equal to minus y. Okay. Let's see what this condition gives. We know that x square plus y square is 1. Okay. That we know. So if x becomes y, if x and y are equal, then what will happen? 2x square is equal to 1, and that will give x is plus minus 1 over root 2. Okay. So this will give you one more critical point. So what are those critical points? Because x is equal to y, so it's plus minus 1 by root 2, comma 1 by root 2. And if x is equal to minus y, then again we get x is equal to plus minus 1 root 2. So how many points we have now? Okay, so now how many critical points we have? In the interior, we have 0, comma 0, we have 1, comma 0, and minus 1, comma 0. We have 0, comma 1, 0, comma minus 1. And this plus minus 1 over root 2, comma plus minus 1 over root 2, and plus minus 1 over root 2, comma minus plus 1 over root 2. Okay, in one of the condition x was equal to y, and another condition x was minus of y. Okay, now we will calculate the value of the function at each of these points and find out which one is minimum, which one is maximum. Okay, so f of 0, comma 0 is 0. F of 1, comma 0 is, okay, let's recall what was our function. So our function was fxy is equal to x square plus y square minus x square y square. Okay, so what is f of 1, comma 0 is equal to 1. What is f of 0, comma 1? Okay, you can put plus minus sign, because okay, because we are taking x square, so it doesn't matter either plus 1 or minus 1. Okay, what is f of 0, comma plus minus 1? Again it is equal to 1. What is f of plus minus 1 over root 2 and plus minus 1 over root 2? This is equal to 1 by 2 plus 1 by 2 minus 1 by 4. Okay, it is 1 minus 1 by 4, and that is equal to 3 by 4. Similarly, f of plus minus 1 over root 2 and minus plus 1 over root 2, that is also 3 by 4. So what is the minimum value of the function? The minimum value of f is 0, and that is attained at 0, comma 0. What is the maximum value of our function? It is 1. And it is attained at plus minus 1, comma 0 and 0, comma plus minus 1. Okay, so there are multiple points at which the maximum value attained. Okay, so the first answer is correct. The absolute maximum is 1 and the absolute minimum is 0. Please note down the problem and the solution. Okay, just note down the problem and the solution. Okay, let's move to the next problem. If you have noted the problem. again, the problem says that you have to find the maximum and minimum value of the function.
Excuse me, sir. Please zoom the question, sir.
Okay. Okay. Okay, you have to find the maximum and minimum values of this function subject to the constraint that x plus y plus z is equal to 1. So your function is has three variables, and the function is x times y times z, and you have to find the maximum and minimum value subject to the condition that the sum of all three variables is equal to 1. Okay, and we also assume that x, y, and z are non-negative. And okay, so we'll use the method of Lagrange multiplier again. So we'll form the auxiliary function. Okay, so let's note what is our function. So functions of it's a function of three variable, x, y, z, and what is our constraint? It is x plus y plus z minus 1 is equal to 0, right? And further we are assuming that x, y, and z all are non-negative. Okay, so our auxiliary function looks like it's a function of four variables, x, y, z, and lambda, and this is equal to fxyz plus lambda times phi xyz, which is xyz plus lambda times x plus y plus z minus 1. Okay, let's find first partial derivatives with respect to all of these four variables. So fx equals yz plus lambda times yz plus lambda, right? Okay, so yz plus lambda. Partial derivative with respect to y is xz plus lambda. Partial derivative with respect to z is xy plus lambda. Okay, and then finally partial derivative with respect to lambda, and that is our function. It's phi. So assume that fx is 0, phi is 0, fz is 0, and f lambda is also 0. Okay, if we assume this, then we'll get that yz is equal to xz and it is equal to xy, and all of them are equal to minus lambda, right? And further our constraint is x plus y plus z is equal to 1, and that comes from this last equation that f lambda is 0. So what can we conclude here? Okay, let's consider first equality. Let's consider this one. Okay, so if yz is equal to x times z, then that means that z x minus y is equal to 0, and that would imply either z is 0 or x is equal to y. Okay, and now assume that Okay, next consider the second equality. Says that xz is equal to x times y. So take x common, we will get z minus y is equal to 0. So this will imply either x is 0 or z equal to y. Similarly, yz equals to xy implies either y equal to 0 or z equal to x. Now we have to find some like those critical values subject to this condition that x plus y plus z is equal to 1. Okay, assume that z equal to 0. Okay, because the first condition said either z equal to 0 or something happens. First assume that let z is 0. Okay, see if z becomes 0, if z becomes 0, then this condition says that x plus y must be 1. Okay, and again assume if x is equal to y, then what will happen? Okay, so there are two cases, either x can be equal to y or x may not be equal to y. So if they are not equal, then we just ignore them. But when x is equal to y, then we have x is equal to half. Okay, so from here what points do we get? We get half comma half comma 0. So this can be one of the critical points. Okay. Similarly, okay, we have assumed that z is 0. Now if x becomes 0, then what will happen? X becomes 0, then because we have already assumed that z is equal to 0. So if x again becomes 0, x is also 0, then y must be 1. So that will give critical points 0 comma 0 comma no 0 comma 1 comma 0. Okay, likewise we will get several points, and in one of them when not everyone 0. Okay, if all x y z they all not 0, then you can see that x must be equal to y and it must be equal to z, and this will imply that x must be 1 by 3. Why? Because x plus y plus z is equal to 1. Okay, so because the time is over, let me write list all these critical values which we have obtained. So we will have 1 comma 0 comma 0, we have 0 1 0, 0 1 0 comma 0 comma 1, half comma half comma 0, 0 comma half, half comma 0 comma half, okay, and 1 by 3 comma 1 by 3 comma 1 by 3. Okay, now find the maximum value of this function and minimum value of this function fxy z is equal to xyz. Notice that except this particular point, every other critical point contains one of the coordinate 0. Okay, therefore the value of the function at all of these point where one of the coordinate is 0 will be 0, right? So but should I write and what about value of the function at 1 by 3 comma 1 by 3 comma 1 by 3? It is 1 over 27. This shows that minimum value of f is 0, which attained at 0 comma 0 comma 0, and several other points. So there were a lot of points. Let call this set of points as some thing. Let call all these set of points as S. Okay. So attained at points of S. And what is maximum? One by 27 attained at 1 by 3, comma 1 by 3, comma 1 by 3. Okay. So the option D is correct. The minimum value of the function is 0 and the maximum value of the function is 1 by 27. Okay. So just note down this problem and solution. This is the problem. Okay, so if you have noted all these problems, so we'll end our live session here because we are already past the time. So thank you everyone for joining this live session, and we will meet you next week with the next set of the problems.